Good morning, good afternoon, good evening, ladies and gentlemen. And in today's lesson, we're going to be looking at transformations of periodic functions. Yes, I can hear the groans and the illicit cheers when we hear the word transformations again. Yes, I know how much fun we've had with those. So obviously, if you guys have forgotten, transformations is when you take the daddy, the parent function, and you do a bunch of stuff to it and turn it into a different function. So when we're looking at these units of periodic functions, we're usually using sine and cosine. So they do follow a certain amount of rules. So obviously the first thing you would look at is vertical stretches. Okay, so let's say you have the graph y is equal to a sine x and y is equal to a cos x. Okay, what are the rules that apply to this? Well, if a is greater than 1, then you have a vertical expansion, or stretch as you call it. So this is a vertical stretch by a factor of a. So you're going to find the rules for these are going to be more or less the same as when we looked at them before. So if 0 is less than a, which is less than 1, then you're going to have a vertical compression by a factor of a. Okay? So basically, if a is a whole number, it's a stretch. If a is a fraction, it is a compression vertically. Okay? But here's the one difference. A in this case, in both cases actually, whenever you talk about a periodic function, always refers to the amplitude. Okay, so it's also represented by the amplitude. So those are vertical stretches. Let's take a look at horizontal. Okay, so at horizontal, once again, you're going to recognize that these rules are going to look more or less the same. So let's say I gave you y is equal to sine of k of x, and y is equal to cosine of k of x. Okay? If k is greater than 1, now, just like how we looked at it before, you guys remember when we did horizontal stretches and compressions, we always recognized that they happened in a mirror image of each other. So if it was a whole number outside, not affecting the x, then it was a stretch. But if it was a whole number, in this case, because it's greater than 1, and it's affecting the x, which you can see it is because it's right beside my x, then this is not a stretch, it's a horizontal compression. And not by k, but 1 over k, so the reciprocal. So for example, let's say k was 2. Then this would be a horizontal compression by a factor of 1/2. Okay? And if 0 is less than k, which is less than 1, so basically if it's a fraction, where before it was a compression, now it's going to be a stretch. By the same thing, 1 over k. Always by reciprocal. Now in this case, the k also represents something, just like in the first case. K is also represented by the period. So whatever my period is, that's my k. Whatever my amplitude is, that's my a. And the period's always represented because this is usually in a circular kind of thing, because sine and cosine is circular. It's usually represented by 360 degrees divided by k. So let's take a look at how you would actually sketch these. And you can sketch these using 5 things. And I want to reiterate what they are. So how do you sketch? Well, to sketch, you want to find 5 points. And these are 5 very important points, and it will help you basically graph every single periodic function. The first one is the first 0. So the first time it's at 0, so basically the first x-intercept. Second one is the first maximum. The third one is the second 0. You can guess where I'm going with this one. First minimum. And finally, we're going to end off with one more 0. I realize I'm actually putting first here. No, not supposed to be first. Second 0, yep. And your third 0. Okay. So this is you basically finding your cycle. These are the 5 key points that are going to be equally spaced along your x-axis, usually in around this kind of shape. So usually you'd have your first 0, your first maximum, your second 0, your first minimum, your third 0. So, and do. 1, 2, 3, 4, 5. Usually like that. Okay? So let's see how this would work in an example. So in this first example, let's describe the transformations that occur and then graph them, okay? So what transformations happen? Well, in this case here, we have you always want to kind of underline your things here that you have transformations from. So I can see here I have this 3. The 3 is greater than 1, so I know this is a vertical stretch by a factor of 3. And then here I have a 2. 2 is greater than 1, and it's beside my x. So this, in this case, would be a horizontal compression by 1 over 2, not by 2, because remember you always do the reciprocal. Okay? So, now we also want to figure out what is our period, our amplitude, our maximum, our minimum. So let's sketch this out. Let's sketch it out. All right, so one thing you have to know when it comes to sine functions, sine and cosine functions always have a max and a min of 1 to -1. Now in this case here, we have a 3, and the 3 is my amplitude. So this 3 is my amplitude. And remember, the 2 is my period. All right, so if I want to figure out what the actual period is, you know, in terms of the degrees, remember that's where that formula comes in. P is equal to 360 divided by, well, there's 2 there, so 2. So that's 180 degrees. All right? So if my amplitude is 3, that means my max is 3. That also means my minimum is 3. So if my amplitude is 3, that means 1, 2, 3, that's my max. 1, 2, 3, that's my min. Okay? So that's my max, that's my min. I do know it goes in periods of 180 degrees. That basically means that one cycle goes until 180 degrees. That also means that my domain would be from 0 less than or equal to x less than or equal to 180 degrees, because that's how big my cycle is. I also know my range is basically my max and min of my heights, which it goes from 3 to negative 3. Okay, so remember, you want to start from your first 0, then go to your height. So let's start from my first 0. That's my first 0. I want to go then to my height, my first max, my next 0, my minimum, and my third 0. Okay, so let's connect these up. Okay, so if I know that this goes up to 180, that means I know that this point here has to be 180 degrees. Okay, I also know that it has to go by implements of 2. Now 180, well, you're going from 0 to 180. What's the best way I can split this up? Well, the best way to split it up, when would my maximum actually happen? At 45 degrees. Now, why am I going in 45s? Well, that's just 180 divided by 4. All right, so you usually want to go by 180 divided by 4 in that case, because that basically means you're going by 45s, because you want to get yourself some nice equal increments here. And that's it. We've drawn it. So I want you guys to pause and try the other one. You guys are back with me? All right, great. So let's see what we got here. So let's circle or underline what things are different. So once again, you know that's our amplitude, 1/2. That is a number that's between 0 to 1, hence a fraction. Hence, that is a vertical stretch by 1/2. This, on the other hand, 4/5. This would be a fraction, which is a horizontal stretch by 5/4. Remember, reciprocal. So if I want to find my period, remember my period here would be 360 divided by 4/5, which is what my k value was, should give me 450 degrees. And I know my amplitude is 1/2. All right. So my max should be 1/2. My min should be also 1/2. Let's do this. Let's draw it. Now, the difference between a sine and a cosine function is the sine function starts at your 0 and keeps going. Your cosine function, on the other hand, starts from the maximum. So the 0 function is at your maximum. So remember, we're going to be starting at 1/2. That's 1/2. Minimum, negative 1/2. and I know it's going to go till 450. So you're going to be going till your maximum. So the rules for cosine are the opposite case. So you're going to start from your maximum, then you go to your first zero, then you go to your minimum, then you go to your second zero, and then you go to your maximum. Okay, that's how you do cosine. All right, and you connect them. And that's a cosine function. And of course I know that this is at 450. And if that's 0, then how do I do this? Same way we did it before. So 450 divided by 4 is going to give me 112.5. 112.5 plus 112.5 gives me 225, so this happens at 225. And so on and so forth. Domain and range, well, remember your domain and range is your min and max. So my domain would be from 0 to 450. And my range would be from -1/2 to 1/2. Okay, so let's take a look at another example or two. Okay, so this example is a little bit different. Now it's asking you to write the equation with the given information. So it's telling me that my A, hence my amplitude, is 7, and my period is 90 degrees. Well, to find my K value, remember my K value is 360 degrees divided by whatever my period is. In this case, it's 90. Equal to 4. Okay, so I know my K value is 4, in which case I can go y is equal to 7 sine 4x. Okie dokie. So that's one of them. Now keep in mind, I just said write the equation, so this could have easily been also so try out this other one. Pause it, try it. Okay, back, great. So my amplitude is 0.5, my period is 270, so you want to find your K. Remember my K value is 360. Divided by my period, which is 270, which gives me 4/3. Therefore, I can have y is equal to 0.5 sine 4/3x, or 0.5 sine, cosine 4/3x. Okay, so let's look at what we would do if we had a graph and we needed to find the equation. Okay, so let's take a look at this graph. And in this graph, they give us a cosine function and they want us to find out what the equation is. So first and foremost, I know what my amplitude is. My amplitude is 2. Why? Because I have a maximum of 2 and minimum of -2, which means my amplitude has to be 2. So I know A is 2 right off the bat. Next thing I want to figure out is my period. Well, how do I figure out my period? Well, we know that you're going here by every 90 degrees, it seems. So 3/4 of my period gives me 90. Which means P should be 120. And you can tell that right away, even if you're looking at your graph. So K should be 360 degrees divided by 120, which is equal to 3. So therefore, my function is 2 cosine of 3x. And that's it. That's part 1 of transformations of periodic functions. I hope you understood all the concepts, and have a good day.